What up? We're back for a little more coding, a little more of that big O. It's been, hope everyone had a good weekend. I know I did. It was full of kid stuff, which is how my weekends mostly go these days. But it was solid. We're going to hang out for a few minutes, see if anybody wants to come in and join. But until then, we're here. We are going to be doing Boot.Dev. Boom. This is where we're going to start off. Oh, I need to refresh. But we were getting close to finishing the Big O chapter. So, goal for today is to finish these last two. Be out of Big O. And what's next on the list? Sorting algorithms. Ho, ho, ho. Now we're talking. That's what I am talking about. Also on that push to partner on the old Twitch. Need some more people to come hang out with me at the same time. And then I might actually be able to do it. We'll see. But until then, this is where we're at. And we're just going to keep going. We're going to prove that consistency beats personality every time. Bum, 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 bum. Oh, I guess I could post one more time about the old we're here. Oh, I'm excited. I'm ready to get this Big O challenge done. All right, we are getting started. Watch here on x.com, be everything app or at your local streaming service near you. I am pumped. I'm working with somebody at work that was high quality sentence. But we're working on something and I wanted to get them to start doing more videos and they're so nervous. So I shared one of my videos. I was like, look, just be an idiot on the internet. It's fine. Don't worry about it. So I think they're going to start, which is good because I need them to. They have way too much industry knowledge not to be making videos. I take the opposite approach. Zero industry knowledge in making videos. 37! What up, dog? In meetings. Hell yeah, dude. Gesture wildly if you need anything. Deal. I'll just... This will be my signal for you. I'm mostly just going to suffer through figuring out how to code, as always. That's how I roll, baby. Alright. Oh, first we got to do the classic. We got to see what Google Gemini does for our banner. I also have to burp. I gotta stop eating ramen. I need to eat healthier lunches. Spicy ramen, though, is so good. Oh, I love it. Too good. Alright, let's see here. What are you gonna come up with, Gemini? Well, that's pretty good. It's so funny. I should try doing it on a... I want to try it on a different account, because even though I do a different chat every time, it always comes in with this, like, classic purpley neon-y blue. Okay, we're gonna start soon, but I'm just giving people a few minutes. Oh, and if you are here early, and just so you know, I will probably only be going till about 4:45 today, so like an hour 45, because kids have skating, which means I have to get dinner ready so that we can get out on time and actually get them to where they need to be. Because tying up multiple pairs of skates and getting all their stuff ready takes time, you know? It's just how it is. Okay, hold on one sec. Oh, I'm going to try something that I've never done before and post that I'm going to be here on Threads. I had a banger go out on Threads. It was been using Ferryman. Shout out to our boy Kevin Naughton for coming up with Ferryman. It's a really, really good tool. If you like to post in like 1 or 2 places and you want it to go to a bunch of other places, it's solid. Again, I get that these are tiny numbers for tiny influencers, but like, oh God, did I just say that? That made it sound like I'm calling myself an influencer. No. Take that back. Tiny numbers for tiny people. That's better. But it's awesome. So I just post on X because that's the only thing I ever post on, really. And it sends it out to Threads and Blue Sky and all those fun ones. And I just had a post do like 10,000, a video do like 10,000 views on Threads. Or a post, yeah, not a video. That one was a post. I was like, okay, sweet. When you don't even have to do anything. So, Ferryman. I think I have a referral code somewhere. I should probably share it. I gotta learn how to do all those cool, like, codes. I know sort of how to do them, but I just haven't done them yet. Let me see. Do I have a code for Ferryman? Hot Dog! What's up? How you doing? How was your weekend? Uh-oh. What just happened? Oh, I muted my tunage. Hold on. How did I even do that? Maybe I shouldn't be using Edge browser. It was good. I'm using Edge for my music. I needed to keep it separate from Chrome because I wanted OBS to split them properly so that I could play music up from like a video, but then also just have music in the background all the time. And I keep messing that up. Anyways, some binary search. Yeah, baby. What's up, YouTube? What's up, Macalio? We're doing, we're going to do order log n. We're almost done the big O analysis course on chapter on Boot.Dev. We're doing the whole data structures and algorithms course because as soon as I saw it, I was like, yes, I absolutely want to do that. And so we're going to try and finish these 2 today. Hopefully I'll get them and they'll be quick. If they're super slow, then that might be all I get to today because I can only go for like an hour and 45. So we shall see. One day I'm going to figure out how to stream longer and do, like 4-hour streams like the cool guys, but we're not there yet. We're just not there in life. Oh yeah, here though. I was talking about a referral. If you want to use Ferryman, here, use my referral so that I get money. But then this way you can post, like I just post on Twitter and it shares it to all of my other socials and it's really good. And I've started like growing accounts on social media platforms that I never cared about or paid attention to. Now they're growing. So, yeah. Here, I'm gonna do this. It's gonna post to both places because this chat thing is kind of annoying, but whatever. There you go. So yeah, if I hate that it does that because it posts. I'm using a streamer bot, and I hate that it I want to be able to post to everywhere, but I hate that it shows it everywhere on like this one screen. But I like having the multi-screen, so I don't know. Should probably just vibe code up my own thing at some point, but until then, this is what we're doing. We post it 1 time and it shares it 3 times. How fun. Sweet. All right, well, how long has it been? I successfully wasted 11 minutes of everyone's time. Not bad, not bad. I guess that means we should start our course. Hold on one sec. Let me just check the old Twitter. Mikhailo, I can't hear you. I can see your messages if that's what you mean. But yes, I can see your messages. You should be able to see them on screen yourself. Okay, here we go. We are gonna start. Let's see what we can figure out today. So, okay, hold on. Gotta prep the brain for this. Because I know it's gonna be tough. It's gonna be tough. All right. Order log n. O log n. Algorithms are only slightly slower than O1 algorithms, but much faster than O of n. They do grow according to the input size, but only according to the log of the input, which we talked about last time on Friday. And log, as it grows, it still grows, but much lower, much slower. So these are two charts, as you can see. Beautiful. So binary search. I don't need to read all these numbers, do I? You guys can see clearly. Starts at 8. If it's O of n, it gets bigger, the same number of, as much as n grows, it grows. O log of n, it starts off slower and grows, but it's much, much, much slower. So there you go. All right, binary search is when you basically you're chopping in half until you get to where you need to go. Binary search algorithm is a common example of an O log n algorithm. Binary searches work on a pre-sorted list of elements. Clever. Given 2 inputs, a list of n elements sorted from least to greatest, and 2 a target value. So do the following. Set low equals 0 and high equals n minus 1. While low is less than or equal to high, set the median, the position of the middle element, to low plus high. Is double slash in... What is double slash in Python? Is double slash modulo? Or am I just making that up? I mean, I could look it up, obviously. What is in Python? Let's see what Gemini says. Oh, floor division. Got it. Got it. Got it. Good old integers. I forgot. So basically, if you're asking what the double slashes are, the double backslash, they are floor division, so it rounds down. See? So like 10, 3, 3 returns the largest integer less than or equal to the result. Does that make sense? I think so. Okay. If list, so there's a dictionary. Nightshade, dude. What's up, man? Good to know you're here with the banning. Always a pleasure. Amazing. Hang on, this is Python. You have to spend the first 6 hours of stream fighting package managers BS. No, luckily, this, man, if Lane would start paying me for ad time, this would be great. You don't have to do that because it uses a REPL. So you can just, it's already set up for you. Which is why Boot.Dev is so nice and easy to use. It's awesome. Okay, where was I? Else, if, oh yeah, so wait, sorry. If list, so if list median equals the target, then return true. Else, if list median is less than the target, set low to median plus 1. Otherwise, set high to median minus 1. Return false. Oh, I'm not with anyone else in here? Yeah, dude, YouTube, I mean, listen. I'm new to this. I mean, it's funny because technically I've had an account doing this for like 2 years, but I like to do this a lot for like a month and then don't do it for like 6 months. And then remind myself that, shoot, I really need to go back and do this. And then do it again for like 2 weeks and then bail. So we're on week 2 of my return. So we'll see what happens. I love the chat overlay exposes NSD shenanigans. I know, right? Could you imagine if it was hidden? Think about what he'd get away with. It is funny. Like, I'm pretty sure you're not supposed to, like, show that chat that shows everything. But, whatever. If it really is, like, if I do anything as well, it'll just show it on the chat. So, there's no hiding. There's no hiding on stream. Raw honesty here in this chat. Okay. So, at each iteration of loop, we have the list, which makes the algorithm O log n. In other words, to add one more step to the runtime, we'd have to double the size of the input. Man, that's huge. Binary searches are fast. That is true. I think. I know it's true because Lane just told me in this sentence. Assignment. We have a popular influencer using our locked-in app, and she needs to be able to quickly search for posts from a particular day. This function will be the backbone of her search screen. Okay. The input array R is already sorted for you. Great. So you don't have to sort the array. Fantastic. Okay. Who's ready? Who's ready to struggle? Let's do it. All right. So we have I'm going to take Nightshade's advice. I'm going to slow down. I'm going to remember to try and read what I'm supposed to do. I'm going to do that, and then I'm still going to forget, and I'm going to then sit here going, what am I supposed to do? What is your setup? Setup for what? For streaming or for coding? Right now I'm just using, I just have a Windows laptop that I bought a couple years ago. It's a Samsung Ultrabook 3. Actually super legit. But then for the actual coding stuff, all I'm doing is using Boot.Dev. So if you go to Boot.Dev, you can sign up. You can do their courses. They're awesome. I started using them a couple years ago. Like I said, like everything in my life, I start it and then I bail and then I come back and then I bail. So this is me coming back to it after a little bit of time and being like, with all the AI jazz going on, now's the perfect time to actually remember to learn how to code better. Because when I do coding with AI, I find it incredibly boring, and the stuff that comes out, I'm not excited or interested in at all. Like, it's kind of cool, but I'm just like, I have no attachment to it. So it's like, I actually like when I build it myself. It's more enjoyable to actually sit down and try and solve the problems. So I was like, I should probably learn how to do it a little bit better if we're gonna live that way. So, all right. What were we doing? We were gonna reread the assignment to make sure I know what I'm doing. So we have a popular influencer using our logged-in app, and she needs to be able to quickly search for posts from a particular day. This function will be the backbone of her search screen. So complete the binary search function. It should follow the algorithm as described above. So yeah, Lane already gave us the whole algorithm in pseudocode. So let's see if we can just implement it. So set low. So if we just did this, low equals 0. And high equals... Wait, hold on. High equals n-1 is a list. Oh, wait, the target value is... No, wait. I'm already getting stupid. Low equals 0. High equals... I'm going to try and follow this exactly and still mess it up. So high equals n-1, where n is the array. So that would just be this. Then... Does he actually want to use, like, a while loop in Python? I haven't used a while loop in a long time. I mean, I could do it. Let's do it. While low is... This isn't gonna work. Is it? Is it? Set median, the position of the middle element, to low plus high. Oh man. So median equals low plus high. I'm just trying to write it out exactly how he wrote it out to see what happens. Which is the greatest integer less than or equal to low plus high divided by 2. Okay? If... Oh wait, I don't have a list. I have a array. Array median. Is this actually gonna work? Equals target. If array median equals to target, then return true. Whoops. Else, if elif. What? What is else if in? Oh, what? Oh, I'm too far out. That's why. Wait, why is that happening? What did I mess up? Oh, because I didn't do a thing. Later, buddy. Thanks for joining. Come by anytime. There, that's what I wanted. If list r median is less than target, then low equals median plus 1, else median, high equals median minus 1, return, wait, do I return false here? Uh-oh. Let's see what happens. I tried to follow it exactly as he wrote it. Did I do it? Oh, darn it. Unsupported operand types for list and int. That makes sense. So what do I actually want to do here? Set low to 0 and high to n minus 1. N, a list of n elements sorted from least to greatest. Well, how do you... Oh, is it length of? Is that what I'm actually doing? Length of array minus 1? Like that? Or, oops. Like this? Is that what I'm trying to do? Oh! That is what I'm trying to do! I think I did it. I mean, by do it, I just read his pseudocode. But that's right? Pass 2? That's good. Oh, snap. Here, we're going to pull that up a little bit. Okay, should we submit it? Did we just put a binary search algorithm together? Not bad. Not bad, me. Woo! That's what I am talking about. Ugh. Booyakasha. That felt good, not gonna lie. I'm pretty pumped that that worked out so well. Alright, next one. We're gonna get through this faster than I thought. We might actually get on to chapter 4. Oh, I shouldn't have said that. Why did I say that right before I opened up the next lesson? What an idiotic thing to do. This next lesson is going to destroy me now. I can already tell. Dang it. I know it. I know it's going to happen. Okay. All right, let's try this again. Oh, boy. Okay, name count. Oh, boy. Oh, boy. In Locked In, we process tons of users' names. They are often structured as lists of lists. For example, a separate list of users for each influencer's followers. Assignment, complete the count names function. It should iterate over all the names in the nested list of lists and count all the instances of target name, then return the count. Observe. What's the time complexity of your solution? It should be O of n on the total number of names, but O of mn if you consider m to be the number of lists and n to be the average length of the list. Okay. So, that all sounds great. And I definitely know how to make sure I'm paying attention and implementing it correctly. Without question, obviously I know how to do that. Duh. Okay, so it should complete the count. Okay, how I would do this without thinking about anything else, it would be... So what's the time complexity of... Let's think about this. What's the time complexity of your solution? It should be O of n on the total number of names. So the step should... The number of lists shouldn't matter for the total number of names, but it will matter to the number of lists and to be the average length of the list. Okay. And count all the instances of target name, then return the count. So I have a target name and a list of lists. So, we already did this one basically, didn't we? I think we did this in an earlier thing. So, because we just have a total that we need to figure out. Total names. And then, so for list in list of lists. Now we have the list. We have the first list. And then we need to count all the instances of target name. It should iterate over all the names in the nested list of lists. So we need to, if target name is in list, then total plus equals 1. And that should be it, right? Is that right? So we have a total. Let's find out. We're just going to run it. No, I failed to. I messed up something. What does this list actually print out? Oh, because this is still a list, so I need to do another for loop, don't I? Because if I print this list, it's this. And I need to do for name in list. If that does that, then do that, and then return the total. No. Shit. What? Dang it. What did I mess up here? There's the list. Let me look at these solution answers. So that's the list of lists. That makes sense. Okay, let's just check here. I want to do a couple things. Print the list. I just want to see, oops, what's in here. And then I want to do print. Oh, because I'm an idiot. Because that needs the same name. But really, that should be names. That's confusing. Right? Yeah. That was just... Oh, I gotta stop doing that as my celebration. Should I throw back up the green screen and just make sure I always do this as a celebration? That's how you get the views, I hear. We got it. I think. I'm gonna run it. Submit it fully. But I think we did it. That makes sense. But is that... So this is the thing that I actually don't understand. So, I know we just spent this whole chapter learning about this big O notation and all of this fun stuff. So, in my solution, am I right? Is this O of n? Because that just means it'll grow, because it's just a number of lists, right? So this first part should just grow O of n. But then this is, it depends, this part depends on how many lists and how long the average list is. So that'll grow, right? I think that's right. Let's submit it first and just make sure we even did it properly. Boom! Heck yeah. Can Boots talk to me now that I've already finished it? Is this the right solution? Yeah, what did he use? Oh, count. Well, fine. Fine, Lane, use count. But other than that, inner list. Yeah, I do. Lane's a lot better at naming things than I am. But I got the answer, so that's all that really matters. Let's see if Boots can answer this question. Boots, how can I know if my solution is following the O, N, and O, oops, O, M, N, as described in the observed portion of the question? I got the answer right, but am unsure how to check if unsure how to know I am doing the right big O. Big O, baby. Oh, yeah, this is what I was hoping for. Okay, thanks, Boots. Let's figure this out. Great question. Let's analyze your solution by counting the work. Counting the operations. Your code has 2 nested loops. So yeah, for list and list, for names and lists. Yes, outer loop, inner loop, constant time work. So the outer loop runs once per... Oh, I was totally backwards. So the outer loop runs once per inner list. If there are m lists, it runs m times. The inner loop runs once per name in that list. If the average length is n, it runs about n times per outer iteration. The body comparison plus increment is O1, constant time. Oh, right. Because it's in terms of total elements. Okay, if you define n, capital N, as the total number of names across all lists, then no matter how the names are distributed across inner lists, you visit each name exactly once. That's O of n. Both descriptions are correct, they're just measuring different things. OMN measures it in terms of structure, list times the average length, and O of n measures it in terms of total elements visited. So ask yourself, how many times does the innermost line run? For your solution, the total plus equals 1, or the comparison runs once per name in the entire structure. That's your big O. A subtle bug worth flagging. If target name in names, here names is a string, a single name, not a list, so in is doing a substring check, not equality. For example, oh, right. Oh, wait, no, but that's what I wanted, right? Well, whatever. I see. That's smart. Oh, I see what it's saying. It's saying that by doing in, that means, that's like what we did in the other one. By doing in, it could be anything. So I should do equals because I want to make sure that the name is exact. So we're going to change it because that's right. That makes more sense. I get it. I got you, bro. And the tests don't catch it. See, though, that's one of those fun things about testing. Okay. So I want to ask one other question. So when you say that's my big O, are you flirting with me? No. When you say that's my big O, does that mean that is the slowest algorithm? The slowest part of the algorithm? Or the fastest? We're asking follow-ups here, baby. Great clarifying question. Big O measures the slowest growing part. Okay, specifically the part that dominates as oh yeah, and I should have been able to remember that. So when analyzing an algorithm, you identify all the operations, find the one that runs the most times as input grows. That's your big O. The innermost line of nested loops trick works because that line runs the most times. It's the bottleneck. A concrete example. So print starting runs one time, O of 1. For item in items runs n times, O of n. For A in items runs n times, or O n squared. And print done runs one time, O of 1. So the total work is 1 plus n squared plus 1. As n grows huge, say a million, n squared is a trillion. It absolutely dwarfs everything else. So we say this is O of n squared and ignore the smaller terms. Okay. Why we drop the smaller terms? Big O cares about behavior at scale. Small, constant time operations are noise compared to nested loops at high n. So we report the worst, slowest, most dominant term and discard the rest. So to directly answer your question, I just made that part up. Your big O is the slowest / most dominant part of your algorithm. Okay. It's funny. It totally makes sense. And I just don't know why I didn't quite pick that up earlier in the lesson. But that makes sense. And that is 100%. Now I think I understand it a little bit more. So it's looking at the slowest, most dominant part of your algorithm. Okay. So in this equation, runs once. One's right. Okay. Cool. I kind of want to go back to that original chart. Yeah, here. Okay. I was just looking at something. Sorry. I got caught up in my own head. But we did it! Woo! That was really loud. I'm sorry. We did it. We got through the big O, and I think I understand it a little bit more. I hope I remember it. No, I do feel like I understand it a little bit more. So that's good. I know we're going to be using it more as we go, but I like that one. That was a good lesson. All right. We're on to sorting algorithms. We got through that faster than I thought. So that's great. We'll keep going. Still got about an hour. We might get through a lot. Who knows? Hold on one sec, though. I do have to check one thing. I apologize. Too many things on the go at the same time, you know? You know what I'm saying? Okay. Okay. Hold up. Sorry, I know it's exciting when you can't see what's happening. But this stuff is work stuff, so I have to keep it on the DL. Hold on. Oh, shit. Okay, there we go. I know that is incredibly thrilling viewing experiences over here. All right, let's do sorting algorithms. Sorting algorithms. Hold on, sorry. Oh, more like sorry algorithms. Oh, I wish you could hear that. Oh, that's the best back crack of all time. Oh, that felt amazing. Oh, new person. Okay, sorting algorithms. Almost every action you take in a web app relies on sorted data. Just looking up a user's profile in a database likely relies on a sorted index, which we'll talk about in another course. Fortunately, most programming languages provide their own standard sorting implementation. In Python, for example, we can use the sorted function. Isn't there another word that's like sorted? It's like S-O-R-D-I-D. Isn't that like bad? Not bad. It was a sorted affair. What does that mean? No, I don't remember. God, I'm dumb. Why am I using an LLM for this? I don't know. Because it's fun. And I don't remember. What does sorted mean? Okay, that's what I thought. I mean, it's not exactly what I thought, but it was close. Close enough. Close enough that I can claim that I 100% totally knew exactly what that was before. Okay, let's go back to sorting. Not sorted algorithms. We're going to go back to the sorted function of Python. It is pretty dirty, though, so maybe it should be sorted. That's the list. Sorted items, sorted. Perfect. Assignment. We need to sort influencers by vanity. Complete the vanity and vanity sort functions. The vanity function accepts an instance of an influencer and returns their vanity score. The vanity score should be the number of links in their bio multiplied by 5 plus their number of selfies. Links in bio are weighted more heavily. All right, honest answer. What's your vanity score, do you think? For me, let's see, I think I have like 8 links in my bio using that link tree thing on Twitter. And number of selfies, I mean, I did post a selfie just today in order to promote doing this stream. I am also literally doing a stream where it's my face and I just want the love and admiration of others randomly. So vanity equals high. Hold on one sec. Just need to check one more work thing. Sorry, guys. Sometimes I get distracted with work stuff. It's okay, hold on one second. Just need to respond. morning. Okay. There we go. I might have to answer one more message, but we're going to try and do this. Assignment. Did I read that? I did. All right. So we have two functions here. Oh boy, we're getting back to our objects and classes and all that fun stuff. So we need to sort influencer by vanity, complete the vanity and vanity sort functions. The vanity function accepts an instance of an influencer and returns their vanity score. So I just need to do the last part. So I need to return the number of links in their bio multiplied by 5. So num bio links times 5 plus number of selfies. Okay. And then, oh, don't touch. Oh, shoot. I wasn't paying attention. I need to touch below this line. Okay. Sorry. Oh, I forget how to do these. Okay, hold on. I just need to print influencer because I don't remember how these come through. It's been too long. And then what comes through? Wait, did that come out? Oh, now I'm confused. Do I need to turn that off? Is that actually printing anything? I just gotta make sure that I'm actually printing something. No. Why is that not printing? Ah! Print debugging. It's failing me because I'm doing something stupid. What if I do return influencer? Well, can I at least get a response down here? No. Fine. But it looks like the input is this. I just don't remember how these come through. I don't remember how... It's like, okay, wait, hold on. Let's see if I can remember. It's like this, right? It's return oh my gosh, I don't remember how to do it. How do you pull these apart? What comes through? I need to go back to learning objects. It's been too long. How I know I can call it. Is it like this? Dot num selfies? Is that it? I mean, I'm doing this backwards as I was doing. Is it like this? Is that how you do it? Num bio links times 5? I don't remember. Okay, wait, hold. Let's just try this. And then vanity sort should return a list of influencers ordered by... What happens if I just do return influencers? What does this actually print out? Okay. So this is why I wasn't seeing anything. Okay, so wait, I'm actually getting there. I just need to... One pass. That's hilarious because it was already sorted. I need to actually sort it. So that's just return... Is it just return influencers dash sorted? Oh, no. Sorted... That's right. Python. Sorted influencers? Is that it? Oh, shit. What did I do? How do I do this? What happens if I do this? Can I print? What happens there? Ah! There's not... Oh, wait. I messed something else weird up, didn't I? Type error not supported between instances of influencer and influencer. Oh. Ew. Well. What does this give me? Oops. Okay, so that is giving me my list, but then I need to sort it. Why can't I do that? You can pass a function as a name parameter called key to sort it. To control the metric, the sorting... oh, I have to pass the key. I need to read. Okay, the key, I need it to be... I don't know what I need it to be. What do I need the key to be? It's a tuple. How do I do that? Functional entities convert old, the built-in sort function is guaranteed to be stable. Uses only while defining, for example, sorting a brief sorting. Let's look at these sorting techniques. How do I sort? Oh, what if I do that? That's a dictionary. So string.casehold. The value of the key parameter should be a function or other callable that takes a single argument and returns a key to use for sorting. So I'm in the right area. I just need to remember what I'm supposed to do. Tuples. Okay, key. Oh. A common pattern is to sort complex objects using some of the object's indices as keys. Is there any way... I don't want to do it as a lambda or a name tuple. This is what I really want. Can I just do this? Is instant. Can I just pass tuple? Will that work? Let's find out. Let's find out. Return. Oh, can I type? No. Return. Sorted. Influencers. Key equals tuple. I wonder if that'll work. No. Darn it. Oh, what? Type influencer object is not iterable. Well, fine. Well, fine then. What am I missing? What am I missing, folks? I'm missing something stupid. I know I could just look it up. I know I could cheat, but I don't want to cheat. You can pass a function as a name parameter called... Okay, do I have to just pass a function? Links in bio. And the function, maybe it has to be something like one of these tuple things that was on the instructions. Do I have to do this? Student... Oh! I do have to do this. Okay. So I need to do key equals lambda. And then I need to do influencer. Wait. Influencer. Whoops. What did I mess up here? Lambda influencer is influencer. Will that work? Wait, I know I'm messing something up here, and it's just because I don't remember how to do this. Do I just do? It's gonna be something to do with this, man. I'm telling you. Something to do with this. Influencer, would it be influencer dot vanity function accepts an instance of an influencer and returns their vanity score. Oh, should I name their vanity score or something? What am I missing, friends? What am I missing? Oh, wait a second. No. No. No, no, no. No, 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 no. I'm losing my brain. I've got the first function right. I just need to figure out how to do this. Do I need to name this and then return that? Do I need to set something? No, that's all dumb. I'm being silly. I need to do this somehow. Okay, you can pass a function as a named parameter called key to sorted. And I just need to figure... Oh! 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 Do I need to... Can I... I need to pass this. Vanity. Right? And I need it to be... Influencers? Oh, this is the part... I don't remember how to do these. No, I'm so close. I can feel it. I just don't remember how to do this part. Can I pass vanity? I need... It's a for loop, right? That's what I actually am trying to make. I'm trying to make that because I'm trying to do each one. So that's why I need something like this. Influencer slash vanity influencer. Right? Oops. Is that right? That feels close. Oh. That feels close. Oh! 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 Oh, we got there! Oh, yes! Yes! Read the manual. Coming in hot. Oh my goodness. Okay. Oh my goodness. Oh. Okay, that one felt good. I'm sorry. I have to do 2 seconds of... I have to do just a tiny little bit of work. So I have to pause. But I can't believe I got that. Well, I should submit it and make sure I got it for real. Boom! What? Reading the manual? Figuring it out? What is this? No AI? My goodness. Oh, I can't believe that all kind of came back. That's wild. Oh, that feels so good. Ah! Okay, while I'm flying high on that one, I'm going to do this quick thing for my job. I can't believe it. I'm so excited. So pumped. Oh, wow. Like, did anybody think I was going to get there? I'll be honest, there was a moment where I didn't think I was going to get there. But we did. We did it. Oh, what an absolute legend. Okay, hold up. We're still working on this, sorry. Okay, let's see here. This one. Nope, that's not what I need. I need this. I know you guys can't see this. I'm sorry. I put on something more interesting. Just look at the beauty of that formula that I came up with. Oh, what a freaking genius. That's all you need to look at, is how incredibly impressive that was. Okay. I need an example. Alright, almost there. Sorry. You know how you think you get all your work done, but then there's always a few extra little things that come in? That's what we're doing. That is what we're doing. Okay. What's today's date? 27th. Okay. Boom. Okay. Getting there. Getting there. 5 more minutes. I still can't believe I got that one figured out, man. Honestly, like... Oh, reading that sorted function, I was like, I'm never going to remember how to do this. And we got it. I forgot about the key. And we even figured out remembered how to do the lambda function, sort of. I mean, come on. Come on. What more could you possibly want from your entertainment on this lovely Monday? I don't know. I don't know, man. Okay, almost done. Almost done. Almost done. Almost done. Almost done. Okay, oops. Okay. Microsoft Teams just asked, how likely are you to recommend Microsoft Teams? Oh, Microsoft, you know, I gotta appreciate your willingness to keep trying. Okay, I'm almost there. Almost there. Then we'll go back to the old boot. Dance break. Okay. Okay. Oh, I still can't believe I figured that one out. I'm still beaming over that one. Unexpected and just feeling great. Okay, let's do that. And do that. And that. And that. Oh, shoot. Oh, dang. Click the wrong button. You know? You know what I'm saying? Okay. We're almost there. We're moving along. We're moving quick. Sorry, it's taking a little longer than I thought. I know it sucks when you can't see what's happening. I know some people do like study time and all those other things, but like you don't actually see what they're doing on screen. I don't know what that looks like. Not yet. Maybe one day we'll get there. Bum, 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 bum. Oh, shoot. Sugar, sugar, sugar. Did I not already do that? No? No? Okay, almost done. Luckily, this is a very solvable problem today. Oh, getting more messages. What's happening here? Additional motion in the shed. I don't know. Okay. Too many things happening at the same time. Okay. Oh man. Might end up everyone's needing something all of a sudden, which means that this might not be a very exciting finish to the day. I mean, it was an exciting start though, and getting that thing was very exciting to me. Okay, hold up. Log in now to see. Hit off change quickly. Okay, this is good. All right. TC portal on desktop or mobile. Alright. Okay. I gotta send out this as the old testerooski. Oop. Okay. Sent. Alright, let's check in on this. Send you a preview if you like it. And now, do that. Sure. Send again on Wednesday. I think. Okay, hold on. One more thing. The guy goes down to robotic, I think. Oh my goodness. Okay. So the good news, bad news. Good news is I was only going to stay on for another 30 minutes anyways. But people are needing me, so we might have to go a little shorter. I think I'm just gonna try and do one more thing, one more lesson, and then I'm gonna bail. And let's do it. Oh, but wait, Nightshade, I might actually remember to raid this time. Don't leave right away. I can raid somebody. I'm here. I hate getting caught up in stuff. There's too many things going on. This is why I need just somebody to dump a ton of money on me so that I can just do this all day, every day, and not do any other work, but still afford to eventually send my kids to whatever they want to do with their lives. You know? And be able to buy them clothes and all that fun stuff. Okay, here. We're going to do one more lesson. Then, if there's anybody still in here, we're going to do a raid to somebody who's open or still who's hanging out. And then I'm going to go. Alright. Here we go. I lied. I have to do one more thing. I have to just send this. Will do. Okay. Review and send. So many things to send. Okay, that's good. Review and send and sent. Sent. Done. Okay, perfect. There we go. Okay, got one thing done. Woo! All right, let's finish this. And then we finish the rest. Okay, next lesson. We did sorting algorithms. Bubble sort. Wait! If the standard sorted function exists, why should we learn to write a sorting algorithm from scratch? We choose to write sorting algorithms from scratch, not because it is easy, but because it is hard. That's pretty good John F. Kennedy, I must say. The only time I think about John F. Kennedy as like to do an impersonation of him is do we have any fellow Clone High fans hanging out? He was the best. That JFK impression on Clone High was the best impression ever, and I love it. All right. In all seriousness, in this chapter, we'll be building some of the most famous sorting algorithms from scratch because, oh, that's super cool, actually. I'm excited. It's good to understand how they work under the hood. It's great algorithmic thinking practice. It's fun. I agree with you, Lane. I think it's fun. Bubble sort is a very basic sorting algorithm named for the way elements bubble up to the top of the list. Okay, we're going to watch the video and then we'll finish reading. Let's pause the old tunage. Ba-tink. And play.
Bubble sort is the sorting algorithm that everyone learns, but no one actually uses in the real world because it's so slow. We learn it because it's easy to understand, and once we appreciate how slow it is, the other sorting algorithms are just that much more impressive. It all starts with an unsorted list of numbers. Then we loop from left to right and compare each pair of neighboring numbers. If the number on the right is smaller than the number on the left, we just swap them. Otherwise, we just leave them be. When we get to the end, we just go back to the start and do it again. We repeat this process over and over and over until we go all the way from left to right without making any swaps. Here's what it looks like on a larger data set.
Oh yeah, these videos, whoever came up with those with the sound and all the different sorting algorithms, that was awesome. That was such a cool set of videos. Pretty cool, bubble sort. All right. Bubble sort repeatedly steps through a slice and compares adjacent elements, swapping them if they are out of order. It continues to loop over the slice until the whole list is completely sorted. Here's the pseudocode. Set swapping to true, set end to the length of the input list. While swapping is true, set swapping to false for I from the second element to end. So if the I minus 1th element of the input list is greater than the ith. Why is pseudocode so much harder to understand than just writing the code? Math. Swap the, sorry, then the ith element, swap the I minus 1th element and the ith element, set swapping to true, decrement end by 1, return the sorted list. All right. Assignment. Well, our avocado toast influencers were happy with our search functionality. Now they want to be able to sort all their followers by follower count. Bubble sort is a straightforward sorting algorithm that we can implement quickly, so let's do that. Complete the bubble sort function according to the described algorithm above. All right, so let's turn this pseudocode into Python code. So first we need to set swapping equals true. Then set end to the length of the input list. Oops, why did I write set? I don't know. End equals length of nums. Done. While swapping, you can just do that, right? You don't have to write is true. Swapping equals true. Oh, true is a capital. Duh. True. Okay. Oops. Then for I. Okay, so for I from the second element to end. For I. Is this just a range? In range of second element, 1 is the second element, to end. Then we do this if I minus 1 is greater than the ith element. Is that just this? Is greater than I. Then we do swap the I minus 1th element and the ith element. So swap the I minus 1th element and the ith element. So swap. So I don't even, how do I do that? How do I actually swap them? So if I minus 1 is greater than I, then we need to do something with the list. So we need to do nums I equals nums I minus 1. Is that right? And then set swapping equals true. And then we decrement n by 1. And oops. So we're out. We're out of this if loop, I believe, right? We want to go back to the for loop. Or do we want to go end minus equals 1. And then we're going to return nums. Oh, God, is that right? Uh-oh. Uh-oh. Oh, wait. Wait. Set something to false. Aha! Infinite loop, baby! Oh, I failed both of these, though. Okay, what did I mess up? I didn't actually change anything. Okay. Okay, hold on. For I from the second element to end, so that makes sense. In range I to end, yeah. Oh wait, end plus 1, right? Huh. But it does need to be n plus 1, doesn't it? Because end, well, whatever. I'm just doing it as it said. Okay. If I minus 1 is greater than I, then nums I equals, I'm just changing this, right? Oh, no. That's not what I want. Wait, is it what I want? Hold on. What happens here? Let's do some print debugging. Print I. What is I? Is this actually doing anything important? Oh, why is print not working? What happened to my print debugging? Why can't I do Ah! Okay, hold on. Whoops. Ah! What did I miss? Set swapping to true. Swapping equals true. Done. Set end to the length of the input list. Length of nums. Done. While swapping is true. That's all I should have to write. Set swapping to false. So swapping equals false. Done. For I from the second element, which is range 1, to end, if I minus 1. Oh, wait a minute. Do I need to do this? Is greater than nums I. Do I need to do that? No. Oh, wait. Oh, I did do something this time, though. Okay, wait. It tried. It tried to do it. Okay. Okay. I just repeated. I did something wrong, but I also did something right. Okay. I do kind of think I'm supposed to do this, though. But how can it just be the end? Because isn't that exclusive? Oh, shit. Oh, that's why. Never mind. Never mind. I was wrong. I was wrong. I take it back. Now, the only thing I'm messing up is this part. If nums... Okay, swap the I minus 1th element and the ith element. Do I just need to go the other way? So 1 equals I. Oh! What am I messing up? I feel like I'm so close. Set swapping to true. So 4. Yeah, we got the 4. We got the if. Inside the if, we're setting this. Swap the I to the -1, I minus 1th element and the ith element. We need to... Oh, wait a second. Do I also need to do this? How do I swap them? There has to be a way to swap them in a better way than I'm trying to do it right now. So nums... Because if I do... Wait, if I do this, then it'll already be... It'll be wrong, right? Let's find out. Let's find out. Ah, darn it. Okay. Wait, that didn't even do what I expected it to do, though. So, okay. How do you swap? How can I swap them without... How do I swap them? How can I swap them without just doing the same one? I know I'm getting closer to this. I'm just not right yet. It's like I did some of it, but not all of it. What happens if I do that? Nothing? What am I missing in here? What if I just do this? Well, print num should just give me the same thing, right? Should just give me that. Yeah, okay. So that's good, I guess. And end minus equals 1 should be fine. Set end to the length of the input list. Yeah, length of nums. That makes sense. If I just do print end, I just want to see if this is counting down. It is. Good. 2, 3. Do I have to start at 0? Am I just an idiot? Was I actually supposed to start here? Oh, okay. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's good at least. But oh, do I need a temporary list? But it doesn't seem like I do. It's trying to say, like, it didn't give me instructions to build a separate list. So what am I messing up? I'm missing something. It's something to do with this, but I don't know how to swap this properly. Is there like a swap function that I'm missing? I need to take, I have a list. Let's say I have 1, 2, 3, 4. Well, we'll say 4, 3, 2, 1. I need 4 to go to move, but I can't lose the one that it's swapping with. And that's what I'm doing right now. Right now, I'm losing the one that it's swapping with. And also never getting 3 to the, hold on. If the I minus 1th element of the input list is greater than the ith element, that's what I'm doing here, then swap them. Oh, I'm so close. I know I am so close. Okay, we're close. This is it. We're so close. We have, so 1, 2, 3 all on the same line. Swapping 2, 3. If I'm just messing up the swapping because I'm not swapping them properly. And how does one swap? I can see that I'm doing something wrong here. I know that part. If I print this, will this show me what it's doing the whole way through? Yeah, okay. So it's taking 5, 7, 3, 6, 5. It's swapping. It's swapping. It's just I'm not overwriting the other part, and I don't know how to do that. Because this will be, if I print these, are they just going to be the same number at this point? Oops. I don't need this. Oops. That's not what I wanted. Where's 10 coming from? 10. Oh, because I'm adding them because I'm a fool. 5, 5. Yeah, okay. So that's, they're the same number. That's the only that's the part I'm missing. The part that I'm not doing properly is I'm not swapping them. I am overwriting them, and I don't know how to swap them. Because as soon as I do this, it overwrites it, which makes sense. I understand why it's doing that. The only thing I can think to do, though, is to set... there has to be a swap key. There has to be something to do, an easy way to do swap. But if it's not, then I'm just going to do it this way. So we're just going to set something because I don't know what else to do. Temp equals nums I. Nums I minus 1 equals nums I. Nums I equals temp. And that should work, right? No? Darn it. Dang it. Oh, wait. Wait, yeah, why didn't that? Wait, what? Oh, because that didn't actually change. This needs to be nums. Oh, I'm so dumb. Nums I minus 1 equals nums I. That makes sense. Oh, this needs to be nums I minus 1, right? Okay, we're closer. We have all the numbers. We just went 5, 6, 7, 8, 3. We started to swap them, but we didn't swap them completely. But we kept all of our numbers, so that's good. Did I just do them the wrong way? Oh, that was all. Wait, what did I even just do? Oh, because I had to start at 1 instead of 0. I did it! That was anticlimactic. But how do you do a swap? Is there a better way to do this swap? We're going to find out, because we're going to see if this goes through. Okay, just making sure. Yep, that works. Submit. 7 passed. That's great. What's the solution? What is the way? Oh, no way! Hey, I was right. I thought for sure there was going to be a better way to do that. Yeah, man. Crushing it. What did it not like of mine, though? What is it mad at that I did differently? Oh, is it just because I did this? What else did I do differently here? Return nums. I did that. Fine. Swapping equals true. What the heck did I do differently than you? Nums. Oh, I see. They have spaces. That's all. Is that it? Is that the only difference? And why does return nums? Oh, it has an extra space underneath of it. That's it? We did it. We did it. Okay. Well, I actually ended up being almost close to how much time I wanted to spend today. Anyways, I saw that Mr. Loki came on. So if anybody's still in here, I'm going to go ahead and raid Loki again. Because why not? I thought I saw him. Where's my following? Yeah, there he is. Okay. He just got started too, so everyone can get in there. This was fun. Thanks, peeps. I'll see you tomorrow. I'm going to start a raid on Mr. Loki. And I will see you all another time. Starting the raid very shortly. In 2 seconds. Thank you for joining me, everybody. We'll see you tomorrow. Bye.